Tonight we have Howard Parkin from the Isle of Man presenting Aurora, Fire in the Sky. Inspired by the space race in the 1960s, Howard has been an enthusiastic astronomer since a child and has become an accomplished and entertaining speaker on the subject throughout the world. He holds a teacher certificate, an Open University degree in astronomy and earth sciences, and the Executive Certificate of Management. Howard has been teaching astronomy to adult education classes since 1985. He's a founder member, former chairman, and is currently the vice chairman and press officer of the Isle of Man Astronomical Society. He is a member of the British Astronomical Association, the Society for Popular Astronomy, the Society of Satellite Professionals International, and the Astrospace Stamp Society. In July 2013, in recognition of his work in education and outreach, Howard was elected as a Fellow of the Royal Astronomical Society, and in 2019 was awarded an honorary B.Ed degree by Chester University. In recent months, the use of Zoom and other social media platforms have enabled Howard to be able to offer lectures online, and he has successfully undertaken several online lectures for various educational institutions, clubs, and organisations. And tonight presents Aurora, Fire in the Sky. Can we please give a warm Mexborough and Swinton Astronomical Society welcome to Mr. Howard Parkin.
Thank you all very much indeed. That's very kind of you. It's a pleasure to be here, and it's particularly a pleasure because 10 years ago, about almost to the day, I went and did a, I've forgotten the word for it now, an audition to become a cruise ship lecturer. And the lecture I gave to them is the lecture you're going to get today. Plus, it's been updated consequently. So I hope you enjoy it. It's always been one of my favorite lectures because it got me into cruising and around the world on various cruise ships. So I'm indebted to this lecture. So when I sent you the list of my various lectures, I was pleased you picked this one. And over the years now, it's grown, and it's amazing how you keep finding more material to make lectures. You've already inspired me to do one about the commercial exploitation of space and to be an astronaut or not. So that might be available in about 6 months' time. But without any further ado, if I go to share screen, hopefully you will get my title picture there. I will.
Okay, we've got your title picture.
There we go. I hope I spelled Mexborough right. I'd never heard of Mexborough till you got in touch with me.
That's fine.
But you're South Yorkshire, aren't you?
We are.
That's right.
That's good. Well, I was there not long ago. I went driving. Well, I went down to London to see my son in St Albans, so we were near South Yorkshire, but it's not that near. Okay, so this, let me just get rid of that on my other machine here. There we go. Right, so the Aurora. I'm sure quite a few of you have seen the Aurora over the years. And it's something that is one of those things that it's a must-see thing you have to do. I'm just putting that up. There we go. I need to just move that to there. Now I can see some of you. Right. So the Aurora has been a fascinating object for millennia. And this is an opportunity for me to talk about it for you. And just out of interest, I can only see about 30 of you on my screen, but just wave your hand if you've never, ever seen Aurora. Oh, there's a few of you never seen the Aurora. You need to come to the Isle of Man. You need to come to the Isle of Man because we see the Aurora from the Isle of Man, as I shall show you later. But now, why is that not working? Here we go. Why is that not working now? Come on, here we go. Right. In 2009, Joanna Lumley, some of you may recall, did a program called In the Land of the Northern Lights. And I think this was the year of astronomy, if you remember, the International Year of Astronomy at the time. And I think this did a huge amount of work for astronomers, or a huge amount of advertising for astronomy as a subject. And of course, Joanna Lumley being Joanna Lumley, she did it very well indeed. And I think it did inspire lots of people. Going back to when I started lecturing on the ships, just to start us off, the first cruise I ever did was a cruise to Norway, and it was called Seeing the Norwegian Winter. Not a word about the Northern Lights, but of course we saw the Northern Lights, and now most cruise ships and indeed land-based trips advertise trips to the Aurora extensively. But the Aurora, of course, there's lots of things we can talk about, and I intend in the next 40 minutes or so to go through it. Basically, I've got a series of topics for you. What is it? Who first saw it? What do we exactly see? Where do we see it? Who explained about it? Exactly why do we see it? What happens? Why do we see it? What colours do we get in it? When might we see it? And finally, can we predict it? And there's a surprising end to this talk because something happened a few years ago which I couldn't make it up. But moving on. So firstly, what is it? Well, this is a classic picture of the aurora in the Arctic Circle. The distinctive vivid green colours which do appear to the naked eye but are seen much better through the cameras. This particular image is a great picture, but you get this flickering idea of these lights in the sky, which are seen not all the time, but sometime. And it's the elusive nature of the aurora that I think it makes it even more special. You can have a lovely clear night up in Norway and no aurora whatsoever. The next night, it'll be blazing across the sky and you'll be breathtaking, absolutely breathtaking views. It appears in a narrow belt around the poles, the north and the south poles. If you look very closely at this picture here, I'll use my arrow, you can see the stars here of Ursa Major, the plough. And I often get asked when I'm doing aurora trips, how do you know it's aurora? With the naked eye, you don't get this lovely colours effect. Can you see stars through it? If you can see stars through it, it's aurora. Because it sounds silly, but if you've got clouds on the northern horizon and you're not sure if it's an aurora developing or something else, or clouds basically, if you can see the stars through it, then obviously an aurora is developing or is about to develop. It can fade away again, but seeing the stars through the aurora is indicative of what might happen sometime in the future. And we have a whole host of different shapes, sizes, colors and structures which change in time. The one thing you can't do particularly easy on screen is show the aurora moving as well as it does to the naked eye. Of course, when you're all looking at your computer screens now, you've got vision of what, about 20 degrees, depending how far away from your screen, 20, 30 degrees width, 20 degrees height, possibly. Well, the aurora can be seen over the whole sky. A similar situation to that is when you tell people about looking for the constellation Orion, you show it in a book or a magazine and it's that big. Of course, you see the real thing in the sky, it's huge. And aurora is just the same. Some things are better seen with the naked eye. Take all the pictures you want, but there's nothing quite like seeing the aurora on a decent night. I can truthfully say I've seen the aurora once, absolutely spectacular as I've ever seen it. I've seen lots of little bits of aurora, but I've seen one night in particular, which we'll come on to later in the talk. It was breathtakingly spectacular. And it spoilt me because that's as good as it gets. It's never going to get any better than that for me. But I still look out for it. Indeed, we'll be looking from the Isle of Man at the northern horizon in the next few months when we get towards September. But moving on. So who was the first people to see the aurora? Well, the first aurora was first seen in the caves in Lascaux. Or I don't say it was the first place it was seen, but in the caves in Lascaux, in the caverns there in southwest France, there are drawings on the walls of the caves that clearly show that there was something visible in the sky. Now, just think for a moment that when we're in southwest France, we talk about seeing the aurora in Norway, Iceland, Canada, Russia, Finland, possibly Scotland, possibly the Isle of Man, maybe on the coast of Yorkshire, but you don't tend to see it further south than roughly the middle of Britain, unless it's particularly spectacular. And here, 31,000 years ago, they were recording aurora visible in the caves of Lascaux down there in the Dordogne in southwest France. So that must have been some display that inspired them to do these drawings on the cave paintings, which we can see to this day down there in Lascaux. There's lots of legends and lots of stories about the aurora, and some people regard the aurora as a celestial battle. Now, I'm sure quite a few of you have heard the story about meteors. They used to believe that meteors were two knights fighting together, and when their swords clashed, you got a spark, which was a shooting star, or a meteor, as we call it now. Well, the same story applies to the aurora. They believe they were the two armies facing off each other, fighting in the sky. Because I always talk in all of my lectures, the one thing that comes across is observational evidence. And it's as true today as it was all those millennia ago. What you see with your eyes, you describe and you explain with your brain or your idea. Even analyzing a computer program, piece of paper, whatever, you're using your eyes, you're using observational evidence to explain something. Copernicus saw the world was orbiting the sun. Up till then, they all thought the Earth was the center of the universe. Observational evidence changed as obviously people like Newton and Galileo added to that saga, but that's an entirely different story altogether. The Norse, of course, because of the prevalence of the aurora in Norway and places like that, the Norse myths abound about the fact that these lights in the sky are from the shields and armor of the Valkyrie, the female warriors. And the aurora was believed to be a Bifrost bridge which glowed and pulsated. I don't know if any of you have watched the Marvel films. My grandchildren made me watch all the Marvel films recently, and they keep going on about this Bifrost bridge. And everyone keeps thinking it's a fictional thing that the Marvel films are about. The Bifrost Bridge is something that the Viking culture talks about for many, many years ago. And of course, it's been turned into a popular concept now by the makers of their popular films. And there's a lovely quote that when they ride forth on their errand, their armor sheds a strange flickering light which flashes up over the northern horizon in what men call the Aurora Borealis. And I can't read my own writing because the screen thing is right in the way. Never mind. If I get the words wrong, you know it's because the UR screen sharing thing is across the bottom of my screen. Who first saw the aurora? Well, the first people to see the aurora also believed that the red aurora represent possibly an outbreak of war. And there's another lovely story about ancient Greece, back by Tiberius back in 37 BC. We saw a red glow in the northern skies over Greece. Again, Greece, Mediterranean, seeing the aurora, it must have been truly spectacular. And we do occasionally get these spectacular auroral displays where aurora can be seen as far south as the Med and indeed as far south as Florida. I was talking to some people from Florida a few years ago, and they had actually seen the aurora in northern Florida. Again, that must have been quite a spectacular display. But such was Tiberius's fascination with this red glow in the sky, he sent firefighters to Oster to tackle the blaze, which they saw in the sky. The Romans, of course, have Aurora as the goddess of the dawn, renews herself every morning to fly across the sky, announcing the arriving of the sun. And again, if we go back to ancient astronomy, the ancient models of the solar system had the sun being carried on the sun god. Ra was carried on the boat every evening, defeated the forces of darkness, and arose victorious the next day. So many of these myths and so many of these legends have the same basis, again, from what I would describe as observational evidence. The northeastern Indians, or the Inuits as we properly call them these days, they had an entirely different view of what the aurora was. They believed that the sky was a huge dome of hard material arching over the earth, and there were holes in this dome, and these holes you could see the light shining through, which was the stars and also the aurora. Some wonderful legends, and it's a great subject to look into if you've got the time on a cold winter's night when there's no stargazing. There's some great legends you can learn about the aurora. The Germans, of course, much more functional. They believed the aurora was candles. They believed that the aurora was birthday candles shining in the sky to celebrate the gods' birthdays. I made that last bit up, but why else would you have candles in the sky? But that's just one other belief, that these different coloured candles were strewn across the skies. And Galileo, of course, famously, who defended the Copernican view, who used his first telescope in 1610, he believed the aurora, or he named the aurora, him and Gassendi, they think a few years later, named the aurora, which is simply the words for Latin for lights and north. So the northern lights is the Latin term Aurora Borealis. So what do we get to see when we see an aurora? Well, the aurora can start off with arcs and bands and can suddenly light up the sky and spread across the sky quite spectacularly. I need to turn my volume up for the next bit. You can also get patches of light that just literally glow and they pulse and they fade. And then we also get rays. In 2000, I'll come back to this in a minute, we had a wonderful auroral display in April 2000, visible in the Isle of Man, where I live on the east coast of the island. I haven't got a northern horizon view, but I could see the auroral rays from my home here in Onken in the Isle of Man quite spectacularly. The most spectacular form of aurora, though, are the curtains. And I do find when you see these curtains, they are spectacular. And I managed to find a short video clip, which will hopefully work. This is sped up quite considerably, but you get this effect of literally these curtains waving in the sky. And you can see the stars there again quite clearly through them. And these are probably the most spectacular forms of aurora you'll get to see with the naked eye if you get somewhere where there's a decent display. Despite what I've just said earlier about seeing it from the Mediterranean, places like that, I would always say the further north you get, the more chance you've got of seeing some spectacular aurora. Again, auroral rays or corona, these can really come to the fore when we get an auroral storm. And we do get auroral storms on quite regular occasions, usually at about 11-year intervals, and I'll come back to that again in a moment. We also get what we call all sky colours, and these all sky colours, literally, you saw red a bit earlier talking about the guy in Greece there, Tiberius, but these all sky colours can be quite spectacular. And these tend to be seen from lower latitudes. What you tend to see is the intensity of the aurora in the northern areas, the Arctic and places like that. You get the reds and the greens and the lower aurora. The higher up aurora, the deep colours, if you like, the solid colours, you're looking at over the top of the aurora. So they tend to be seen more prominently from places like the middle of England or the Isle of Man or Ireland or places like that. And that's why we tend to see, that explains the red aurora seen in Oster or near Oster in Greece all those years ago. What's happening? My screen's not letting me move. Here we go. Hope you, yes, what do we say? Yes. The song, someone's just asked me, Sandra's just asked me about it. And someone's already answered. David's answered. Northern Lights by the group Renaissance. Fantastic song. And I owe that song to my career as a cruise ship speaker, because I played that song and the owner of the company came out and said, who's playing that song? It's a wonderful song. And why is he playing it? And I said, I'm talking about the Aurora, and this song couldn't be more appropriate. So here we are today, and that's why I did it. And it's a great song. And you can get it anywhere on the internet or ask Alexa for it. No, I shouldn't say that. My Alexa will activate itself. Go away. Don't open. Don't start on me. So where do we see the Aurora? We see the Aurora, obviously the Aurora Borealis, as you've gathered by now. The word Latin Aurora is lights, Borealis is north. But we don't just see it in the north. We see it in places like Alaska, Canada, Greenland, Iceland, Norway, Finland, etc. But we also see it, and this is the geographical map showing where it is with the Aurora there in the green and the blue. But we also get to see Aurora in the southern hemisphere. But you'll notice the big difference there, although the latitude is the same, it's south rather than north, of course, none of the auroral areas there go over occupied land. Yes, there are people living in Antarctica now, and sometimes the Aurora can creep up into South America and into New Zealand, for instance. But you don't get as much Aurora because you haven't got the land. You haven't got the people living in the population areas anywhere near the Aurora in the southern hemisphere. But the Aurora Australis, of course, same terminology. Aurora means light, Australis means southern. And it's always a bone of contention when you talk to Australians. A few times I've been talking to some Australians on cruise ships, and they say we've never seen the Northern Lights. And of course, we might be cruising around Iceland or somewhere, and you've got a good chance if you go on a cruise of seeing the Aurora. I don't think I've ever failed to see the Aurora whenever I've been on a trip to the northern areas. It's not been very good sometimes, but you always get to see something in the sky, if not a spectacular display. As I say, the Aurora Australis doesn't appear over any populated areas. The other thing to talk about, of course, is where do we see it as regards the height? I'm sure some of you have been looking in the last few weeks for noctilucent clouds, and we've had a few decent noctilucent clouds seen. A few from the Isle of Man, but I've got a friend who works in Edinburgh, and he's seen loads of noctilucent clouds. And the noctilucent clouds are very high up, as is the Aurora. We're looking at roughly between 160 to 480 kilometers above the sky, above the Earth, sorry. roughly at the height of the space shuttle and the rockets, according to that little graphic there. And there are some great videos, and I'll show you one later, of the aurora seen from space. The aurora also features quite extensively in the quest for the Northwest Passage. The idea that there was a passage across the top of America that would lead from the Atlantic to the Pacific, and indeed people have done it. I understand in recent years they've talked of sending cruises through it. The problem with that is if there's an emergency, you can't evacuate a ship up in the top of Canada. So I can't think the equivalent of the FAA, but the safety board that look after cruise ships have refused to give permission for cruise ships to go through the Northwest Passage, even though I understand it has opened up to a degree because of the melting of the ice. But the rays of the aurora down the bottom left there and up in Alaska, and they do get some spectacular displays in Alaska as well as in Norway. We tend in the European area to think about Norway and Iceland more, but Alaska, of course, is a very good place to spot the aurora from. And this is where we tend to see the aurora. The aurora is pretty well based on a oval. Sorry, I've gone too fast. The aurora, as you can see there, the green line is the extent of where you will see it. This is at a lower level of activity, and the actual aurora will be overhead where it's green on my diagram. So of course, if you're further north, if you're in upper Greenland, or maybe up here in Canada, up in the top of Alaska, maybe, you might not see the aurora quite as in the north. You'll actually see it in the south. And the aurora tends to peak like this. We have an index called the KP index, and this shows, I'm using North America as an example here. You'll notice that the green bit here is just at the bottom of the Great Lakes on that first one, and KP2, it's further south again, and on this one you're actually starting to get the northern part of America, of the USA, into it as well. And if we go on to the next slide and we get 6, 7, 8, and 9, you'll see here, this is the one where they'll see it in Florida. And this is all to do with the amount of auroral activity. The more auroral activity you get to see, the greater the display, the further south you'll see it. You'll notice that whilst the auroral oval does drop ever so slightly, it doesn't drop very much at all. Let's go back a second. You can actually see that the northern edge of the aurora doesn't change. It's the southern edge that drops further south. And that's why you want to be as far north as you can get. If you want to guarantee aurora, if that's such a thing you can do, you've got to go inside the Arctic Circle. But even that doesn't always work. Oops, wrong button, sorry. I need to press that button there. There we go. And sometimes we can see aurora from the Isle of Man. The first time I ever saw any aurora myself was in the Isle of Man in April the year 2000. And our society chairman, he's our chairman now, I was chairman then, he took this picture over the dome of our observatory in Foxdale. And this was a very spectacular display. I think lots of people, if you look back historically at people's aurora photographs, there's lots of people saw the aurora of the 6th of April 2000. I'll talk about the timing of the aurora a bit later on, but you do get these peaks every 11 years or so. And 2000, 2001 was a peak, 2012, 13 was a peak. The next one will be 23, 24. The first time I got to see it from a cruise ship was on the Norwegian-Finnish border. We took a coach, and there's about 6 coaches went up to the border of Norway and Finland. And the 3, 4, 5 coaches in front of us, I can't remember how many coaches there were now, they didn't see a thing, but we were late because we got held up by the traffic police. And so they let us stay a bit longer, and look what happened. The aurora came out. And that at the time I was just so delighted to see that. It was so spectacular, much better than I saw in the Isle of Man. But I was in Norway, there was snow on the ground. It was just a magical moment for us. But then a couple of years later, forget the zoom for the second. I'll leave the zoom on. No, I'll take that off. Take that off for a second. Hang on. Just bear with me. There we go. No, I can't stop that coming in. We're on board a ship in Tromsø in Norway, and we talk about the auroral oval, and this is not the auroral oval. This just happens to be an oval shape of aurora in the sky. And this picture was taken in the middle of the city of Tromsø in March 13. And what makes this particular spectacular for me is this is me. And this is my wife. We were sitting on the ship inside, minding our own business. I'm just going to do that again. And there we are down there at the bottom. And that was the night before I'd done a stargazing session on deck for the passengers, and we saw no aurora. It was a spectacularly clear night, no aurora, and everyone was disappointed. Next day in port in Tromsø, never look for the aurora when it's a well-lit town. We saw this. And the lovely sequel to this story is I went up on deck and stayed there watching the aurora and said, I'm not going to go to bed until everyone else has gone to bed. 3:30 in the morning, the aurora was still going strong, but I gave up. But I did learn of a great drink when you go aurora watching, and it's French hot chocolate. You have hot chocolate with a brandy in it. You've had 2 or 3 of them. Nobody cares. Moving on. What else do we see? We can see the aurora from space. It was recorded early on in the manned spaceflight program, or the human spaceflight program, that the aurora could be clearly seen from space. And you look at this picture here on the left, you can see the tail of the space shuttle, the payload doors are open, and you can see the aurora quite clearly in the skies, with the green at the bottom and the red and the purple at the top. And we get to see quite a lot of spectacular pictures over the years now of the aurora from space. And this little video clip now, which again I won't talk over, this is a aurora time sequence taken from board the ISS.
Cameras on board the International Space Station have managed to capture the Aurora Borealis, also known as the Northern Lights. Released by NASA, the series of videos show the stunning light shows shimmering over North America. As well as the Northern Lights, one film captures a moving star field over the Pacific Ocean. The images were taken by the crew of Expedition 30 on board the ISS between June and February this year.
And I understand they do see the aurora quite spectacularly quite often. Of course, they don't have the problems with the weather. They can always see the Earth. They don't have clouds in the way like we get from time to time. We also see the aurora on the planets. We have spotted aurora on Jupiter and also on Saturn. And we now understand the principle of the aurora with the rotating magnetic field and all the rest, causes the auroral displays. And there is evidence, I've not seen any photographs of it, but there is evidence that there may be aurora on Mars as well, but that's not been photographed as yet. Who first explained about the aurora? Well, excuse me, the guy who finally came up with what caused the aurora was a chap called Christian Birkeland. And he, I quote, energetic electrons are ejected from sunspots on the solar surface, directed to the Earth and guided to the Earth's polar regions by the geomagnetic field, thus producing the visible aurora. And so revered is Birkeland that they actually put him on the 200 krona note. And here's one, I've got one for you here. I didn't spend this, I managed to save this one. That's the 200 krona note, which is shown on the screen as well. And that is Birkeland, who explained what the aurora was all about. So just why do we see it? I mean, that very quick explanation from Birkeland there doesn't really explain it, but why we see it is basically because of the activity on the sun. And this short video explains a bit better than I ever could, with some nice graphics included as well, I hope.
On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts, on the sun, a star of average size among billions of other stars in our Milky Way. The sun acts as an enormous power plant. The energy is created deep inside the core of the sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells, These electrical currents of charged gas create magnetic fields inside the sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.
So that's the basic explanation of what we see and why. And we do, of course, get to see daytime, or we don't see the daytime aurora, but there is daytime aurora, which can be detected by instruments, but the nighttime one is the one we want to see. And I've just thrown this picture in now as well. It's a video, actually, because in December 2012, at the peak of the last cycle, there was a huge solar eruption which erupted outwards. And here it is in the whole thing now. You can see the Earth to size there. And this massive flare erupted from the solar surface, but fell back down again. It didn't actually break away, that one, so we didn't get a coronal mass ejection. And of course, the other thing about the coronal mass ejection, which is what we're talking about here when it leaves the sun, is it's relatively small. It's millions of miles across and all the rest. It's relatively small when you look at the size of the Earth's diameter of the Earth's orbit. So the Earth's got to be in the right place at the right time. And if the Earth is in the right place or the wrong place, depending on what you're looking for, it can cause major interference and major problems on Earth with electrical equipment. And I noticed someone put a comment on a moment ago on the notes on the chat section there about the Carrington event. The Carrington event was a major flare-up that took place in 1859, which disrupted an awful lot of electrical equipment. And there is a strong theory that if we had a huge CME hit the Earth at the wrong place in the wrong time, it would cause untold damage to electrical devices such as sat-nav systems, such as navigational system, and all the rest. It is a problem which I don't say it's ignored, but we certainly don't seem to be worried about it too much. We won't get that much warning, and evidence does show things like the Carrington event can take place. So we'll hopefully not get to see that, but it would make for some spectacular aurora if that was the case. But the real explanation is this. The only problem with that one is what explains the aurora australis, because you don't get polar bears in the South Pole, you only get penguins. So it doesn't explain. So observational evidence won't work there because I've never seen a polar bear in the Antarctic, but never mind. The peak of solar activity every 11 years, there has been distinct weakening of the solar cycle since about 1980. The last four, 21, 22, 23, and 24, have shown decidedly lower peaks. But the good news is, and I looked this up only literally a couple of days ago when I was getting ready for this talk, there are already indications that the next peak is going to be slightly higher than the 2012 peak. So there should be more activity, and that prediction has come about because they're looking at sunspots. I'm looking at solar activity using various satellite, and there is a strong indication that the aurora for the next peak in 23-24 is going to be higher than the 2012 peak. It doesn't mean you're not going to see it outside the peaks, or indeed that the peak will be too low to see much. We'll still see aurora. You might see aurora in the next few weeks, but you get more prominence and more spectacular aurora at the times of the peaks. So it would be nice to see if we do get an increased activity, we might get to see some decent aurora from wherever you might live. Colours of the aurora always fascinate people because we do see that the aurora tends to be green. And the amount of times that people have been looking at the sky and they see some white, I'll say clouds for want of a better word, on the horizon, and they'll say to me, is that aurora? Because the human eye sees the aurora more as white than green. It's only when you get the spectacular displays, you get the true colours and the greens and the reds and all the rest. But green is by far the most prominent colour. But a tip I learned many years ago by a photographer is if you've got a camera that's got the ability to open the lens and you're looking for aurora, just handheld, highest ISO setting you can get, just take about a 5-second picture, point it at what you're looking at, point it at what you think might be aurora, point it at the sky, and if it shows a distinctive green glow on your screen of your camera, keep watching, because that is certainly an aurora about to develop. As I say, the human eye does not see the green as much as the cameras do. But the green is the most prominent colour by far, and the green is predominantly caused by the atoms in the oxygen molecules being excited to a different level, and they emit light. We also get all red auroras from high altitude oxygen. This is where the higher altitudes I mentioned earlier. These are also produced from oxygen, but they tend to be red. Again, we can get yellow and green from lower level oxygen from about 60 kilometers high. But the bluer light you get, the rare blue light, you see some of that in this picture here, that comes from ionized nitrogen, and nitrogen also causes the purple and reds we get to see as well. But you're not going to see the colors as vividly. These are spectacular pictures I'm using here, and these pictures will certainly are showing the best of it. The human eye will only pick out the colors a bit fainter than this, but your cameras will show them better. But I still say it's much better to see it with the naked eye. Some great pictures of the colours of the aurora. This is one taken from one of our friends in the Isle of Man in 2012, showing the distinctive bright green with the red and the blue and purple on top of it. There's another one here, the same night. This time it's just got blues and reds, greens and reds. I love this particular picture from the Moray Firth, a beautiful rock structure called the Bow Fiddle Rock. This was in 2014. You'll notice the dates, 2012, 2014, each side of the peak dates of the last auroral peak. And this other one from up in Caithness in Scotland. Again, it's a spectacular picture. And I love the way, I know someone commented on the reflection in the snow, but I love to see the aurora reflecting in water like that. It's a breathtaking natural phenomenon. So when might we get to see the aurora? Well, the best time to see the aurora is going to be usually in about September time. This is another one a friend of mine took, shows the plough quite clearly here. And this was a classic one we saw in September a couple of years ago. And this, it's a true story. We're on deck showing about 50 or 60 people on board, wanted to see the aurora. We were off Iceland and we didn't see anything. I saw what I thought was a glow on the horizon. I didn't have my camera with me. I hung around for a bit longer and about 15, 20 people stayed with me. And we got to see this, which was quite clearly visible to the naked eye. Next morning, we're telling people we'd seen it. They were most upset. They hadn't seen it. We went up on deck every night thereafter, and we never saw any more aurora. So I'm afraid it's something you just can't predict. I mean, this was 2019, well away from the solar cycle, the peak of the solar cycle. But of course, you do get to have a look. If you're further north, it's always worth looking. And I know lots of people have said to me, there's no point going on an Aurora trip on a cruise ship or a land-based trip or an aeroplane even outside of the peak. You can still see Aurora. It might not be as spectacular, but you just want to see those colors in the sky. And I know people have got this on their bucket list, which is a thing I hate, the bucket list, but the Aurora is got a glory all of its own. It's like seeing an eclipse. It's like seeing a decent comet, all these astronomical phenomena we love to see. And the Aurora is certainly up there as a must see for anyone interested in astronomy at all. September 2019, there was a nice auroral display, which someone very kindly made a time-lapse film of. Notice they always put nice music to these as well. I'm just looking at the questions while I'm playing that. In fact, while that's playing, yes, the auroras do overlap. You do get auroras right through. You don't necessarily just get one stretch of aurora that then dips to nothing and then goes back again. The aurora can be seen all the time. There's no distinct peak of actual aurora activity. It just goes all the time. Yes, I'll put the video. It's a National Geographic video, that one. I will put the line up, the details up later. And yes, the generals do occur around, the best auroras occur around the peaks, but not always, as I mentioned earlier. The other thing I can talk about is what to look for when you're looking for aurora. Sounds stupid, but if you're in an area where you're likely to be seeing aurora, if you're up in Iceland or Norway or Alaska or even in South New Zealand, check the sky. I'm sure as astronomers we all do that, but there was a famous time when someone told me it's a clear night, and I went downstairs and got my cold weather clothes on, went back upstairs on the ship I was on at the time, and it was a blizzard. I hadn't checked the sky. Someone had said it was clear. Half an hour later, I went downstairs, got changed, went back up on deck, and it was an absolute blizzard on deck. I hadn't checked the sky before I got bothered getting changed. So always check the sky. And remember, I don't need to tell astronomers this, but astronomers know this one, but make sure you get your eyes dark adapted. It's so common for people to, meteor showers are a classic. The Perseids coming up next month, and people will say to me, well, I put my head outside for 5 minutes, didn't see anything. It was clear night, but I didn't see any meteors. Don't think about it, because you've got to get your eyes dark adapted. And it's exactly the same with aurora. Use your camera as a detector, which is what I mentioned earlier. If you get this green glow anywhere in your screen, keep watching, it may well develop. And don't just look to the north. A few years ago in June, way outside the time for seeing aurora, we had an aurora in the southern sky of the Isle of Man, which broke all the rules, but it was a distinct aurora and it was well worth looking for. So do focus on the north. Yes, it's like meteor spotting. Look at the northern area, or where the shower's coming from, but look each side as well, because you may find aurora developing on maybe the western or eastern horizons. And the other one, of course, is you can't, if you're going on a cruise or a trip to the aurora, try not to pick one when the full moon is going to occur. The cruise ships don't think about this. The cruise ships will have the ship in the middle of the Arctic Circle when there's a full moon. And obviously from a point of view of seeing aurora, that's the worst time of the month to see aurora, because the moon will interfere with the lower light levels you need to see. When might we see it? Sorry, we've done when might we see it. So can we predict it? Well, I've already mentioned the KP levels, but basically it is difficult to predict, but sometimes we can predict it a few days ahead if we know there's been any particular activity on the sun. The aurora tends to peak at the time of the equinoxes, when the sun is over the equator. So the best time to see aurora is always March and September. And indeed, there's always been the months that I've tended to see it. Whenever I've been up to Norway, it's been in February, March time. And another time I went to Iceland, it was in September. The commercial companies do aurora spotting throughout the winter months, but you're not as likely to see it in November, December, January as you are in September, October, and February, March time. So that's worth looking for, or worth bearing in mind. And as I said, the darker nights are from February to April and from August to October. Although, as I mentioned earlier, I did once get to see the aurora in June in a southwestern sky. Statistically, the best time to see aurora is, I can't read my own figures here. I don't, you can. I think it's 9 till 1, but really the best time is late as possible. That one I saw in Tromsø, we were inside the ship doing a quiz, and someone came into the bar and said to me, "Aren't you that astronomy fella?" And I said, "Yeah, why?" He said, "Get out here and look at the aurora." And that was when we saw it in Tromsø. So yes, statistically, it's like saying meteors are always visible after midnight, and it's always well worth looking. If you're in an area where you've gone to see the aurora in particular, turn your lights off, sit there in the dark and see what you see on the horizon. It's well worth the wait, I can thoroughly assure you. Now we know the solar radiation or the solar wind causes the aurora, but we can get these coronal mass ejections. And when these do occur, if the Earth is in the right place, roughly 3 days after, which is what the film told us, you've got a chance of seeing some aurora. It could be quite spectacular, but it doesn't always work that a CME will cause an aurora. For reasons not quite understood, not every CME causes an auroral display. Most do, but not all. So we can have the hottest prediction out of there being an auroral storm going to take place in the next few days or hours or whatever. Some great apps you can get on your phone for Aurora Watch, and sometimes they'll tell you there's a CME coming or a predicted CME, and you see absolutely nothing. So it's all, and that's what I think makes the aurora enigmatic. It really is something special. The sun, of course, does do all sorts of activities. This is in 2017. Note the date 2017, well away from the solar peak.
September 6th, 2017. Looking at our star in X-ray mode. Only the high energy X-rays and extreme ultraviolet light shines, but that's all we need to know the sun has done something titanic. Sunspot number 2673, 131 angstroms of light revealing ionized iron and bright magnetic fields above the sunspot. After months of silence, and the largest by far in the last 12 years. It has released a large coronal mass ejection into space as seen here on coronagraphs. Looking from Earth, the spread tells us that the eruption is coming our way. We call that a halo eruption. The burst appears large and quite dense, and when we look,
and it didn't really develop. There was a little bit of aurora seen shortly after then, but not a great deal. However, in conclusion, I said at the beginning, there's some things that might surprise you, because sometimes even the experts get it wrong. The Aurora Watch people is based in Lancashire, which ironically is where our ferry goes to from the Isle of Man to Heysham, which is very close to Lancashire. And a few years ago, in August 16, they put out an Aurora Watch. They put out a major Aurora Watch, and everyone got quite excited. And this was around noon on the 23rd of August. And we thought, right, it's the right sort of date. It's near September, whatever. And we'll all get out and arrange our Aurora watching that night. A few hours later, they sent a further message. I'll let you read it for yourselves. A lawnmower had gone over the detector. And they cancelled the, you can't get hold of that email anymore, but I managed to get hold of it and I keep it and I use it. It just shows things can go wrong. Even the experts get it wrong sometimes. But it's well worth looking for the aurora. So hopefully sometime in the not too distant future, I hope some of you, if you haven't seen it, might get to see what I would regard as one of the most amazing and awe-inspiring displays in nature. In the meantime, good aurora hunting, and thank you all very much indeed for your kind attention. Thank you.
Howard, thank you for a entertaining talk and informative as well. Could I ask you to, you've already done it, stop sharing your screen, and we're going to let people settle down again and think of their questions. Whilst doing that, can I just remind people, if you can put a digital hand up, that would be lovely. Otherwise, wave at me if you want to ask the question. So we'll start off with David.
Hi, can you hear me?
Yeah,
yes, thank you, David.
Thank you. Lovely talk, beautiful images, and I learned a lot. That was really great. But dare I presume to challenge you on one of your dates? And it's not an astronomy one. Did I hear you right? You said the Roman Emperor Tiberius, BC 37 BC to AD 14.
I think I said Tiberius, but it wasn't Tiberius. The slide had gone some slides previously, and it was a guy in Greece, and it wasn't Tiberius. It was someone else.
Ah, right, because Tiberius was not 37 BC to 14. He was actually AD 14
Right.
to 37 AD died. So
Go back to the slide.
what?
I think it was Titus, not Tiberius, and he was Greek. It wasn't a Roman. That was it.
Ah, right. I thought you said Tiberius. Sorry.
Did when I referred back to the red Aurora, and I said,
right.
I seen Tiberius, and I thought it wasn't Tiberius.
No. Sorry about that, but
No worries. I'm glad someone was
my
listening.
subject. Yeah, thank you.
Glad you're listening.
Okay, we got that sorted out. Howard, one of the things, the images were wonderful. I've been lucky enough to see Aurora up in and around Reykjavik.
All right.
I'm always surprised how images don't quite capture the structure.
No, they don't.
Whether you're talking about rays or curtains, there's a definite streaky structure to the Aurora.
The best I can show is the curtains. That video I showed of the curtains.
Yeah.
Even that doesn't do it justice. The way the Aurora slowly, over literally a few minutes, changes in its structure and its shape and its pattern, that's what the naked eye sees that the camera will never capture. That video I showed, which someone's asked me the question about that, yes, it's all I can tell you. It's from National Geographic, a place called Salten, and just look it up on the internet. And that's probably one of the best videos I've ever seen of it, but they don't do it justice by any stretch of imagination.
And if you're lucky enough, the last night we were in Reykjavik, we went for a meal, and when we came out, we found ourselves in the middle of Reykjavik, brightly lit, looking up at the night sky, and we could still see the Aurora. And we were actually right underneath the Aurora.
Yeah, you would be, yeah.
That ray structure again was very evident, and we were getting all the colours as well. We were extremely lucky that evening.
Reykjavik, of all the places I've been to see Aurora, and I've been lucky, I've been to Alaska, I've been to Finland, I've been to Norway and Iceland, but there's a place in Reykjavik, a shop, a museum, call it what you like, the Aurora, got the name of it now, fantastic place. You could spend as an astronomer half a day there. It was on the quayside in Reykjavik, and I just loved it. They had every film and video and T-shirts and ties you could get your hands on. And
we missed that. We missed that.
You missed a tie.
I'm still. You've been complimented on it once tonight. You're not going to get another one.
All right. Okay.
I'm looking around for questions. If you're not going to give me a digital hand, give me a moment to spot you. Mick Nichols.
I want to ask a question about those cave paintings.
Oh, yeah.
How do we know that it's actually showing Aurora? Because with cave paintings,
because
we seem to interpret them as showing what we want them to show.
I have looked at that picture dozens of times, and I can't work out how they know that's Aurora. But the experts, the archaeologists, tell me this is definitely cave paintings of something in the sky that they say is Aurora. But I'm glad you mentioned that, because it's one of these things that you've got to take the expert's word for it. But I'm thinking, how did they work that out? It just looks like scroll to me.
One of them things that were winding, could actually be a river.
Could be. I don't know, but I'm assured they are Aurora. But you'd have to take it up with the archaeologist, I'm afraid.
Could I just
I've thought that myself many a time.
Okay, Ian.
Yeah, can I just interject there? Because those caves also have other drawings in them. We heard about the other week about drawing, painting, or depictions of what is probably Taurus, the bull, and the belt stars of Orion and the Pleiades. Mm-hmm. So those people were definitely sky watchers. So it does sort of support the theory that it's
credible.
Aurora.
It's credible, but when I look at those pictures, I wish there was somebody had put an interpretation on them. That's a tree, that's an elephant, that's the plough, whatever. But I'm afraid you've got to be guided by the experts sometimes.
Please label your
figure
work.
1, Aurora.
Sorry?
Didn't put figure 1, Aurora.
Aurora, yeah.
Please label your work as per instructions. Mike Oxford.
Yeah, just another Well, it's not a question. It's more of a statement about dates. I'm down here in East Anglia, so you know we really don't get many aurorae this far south. But this one was so memorable. Not only can I remember the date, but I can also remember the star I was looking at, because I only observe variable stars. I was looking at a star called RX Andromedae. The date was November the 11th, 1989.
Right.
And I'm looking at the star through, it's about half a degree of sky you get. And the sky starts to look red. And there was no light pollution. So I'm thinking, you know, why does the sky look this colour? So I draw back from the eyepiece, and the entire sky is just aflame with this bright red aurora. It was fabulous.
What year was that?
That was November the 11th, 1989.
Before my time for aurora. My first aurora, I didn't get into aurora spotting until 2000. So,
yeah.
Okay, although looking at the dates, 11 years before 2000 is 89. So it would
the maximum
as an auroral peak.
Yeah, yeah, it was fabulous.
Well, this is what the aurora does. It's not predictable. We think we're clever. We think we can predict all these things, but nature just sometimes lets go, doesn't it?
Yeah, yeah. I sort of ran in and I sort of said to the other half, you know, wake the kids up. They were only babies. I say, wake the kids up. Yeah, they've got to come and see this. They weren't interested.
No. It's like me showing my daughter. She was, how old would she be? She'd have been 6 years old, and I showed her Halley's Comet through my telescope. And she still remembers, because I keep telling her, do you remember looking at that fuzzy blob in my telescope? So I tell her she saw Halley's Comet. But you know.
Okay, I'm still looking for questions or comments. If you've got one, please put a digital hand up. Otherwise, wave at me. Tom Wade.
Hi, Tom.
Well, it's more of an interesting question, this. I got back into astronomy about 10 years ago through a lecture on a cruise ship.
Oh, good God.
So that was on Aurora in the Caribbean.
Right. Wasn't me then. I haven't been on the Aurora.
Right. All I'm saying is they are extremely good.
Yeah.
And you've got fantastic night skies to play with afterwards.
This is it. I mean, I'm very fortunate. I've done a lot of ships now. I'm actually one of what they call the Viking resident astronomer on the Viking ships. And but they make you, I mean, lectures, I don't know how long that lecture was, but you've got to lecture for exactly 45 minutes, not a minute more, not a minute less. Well, they throw you off. It really focuses the brain onto getting into doing it. So I don't know. I think that was probably a bit longer than 45 minutes because I waffled a bit probably.
Yeah.
But
Caribbean's quite nice. It's nice and warm on the top deck afterwards.
Oh, it's great. I'll tell you a true story though. The first time I went on a cruise ship to the south, across the Atlantic into the South Pacific, I offered, it was Queen Elizabeth actually, and I offered to do stargazing on deck. And I always do, and I usually do it in the Caribbean or Norway or the Med. This is the first time I've been in the South Pacific. And I realized with horror, we were going into the Southern Hemisphere. I had no clue what we were looking at. Fortunately for me, they do their stargazing on the Queen Elizabeth and the Queen Victoria off the stern of the ship. The ship's going south, we're looking north. So I got away with it.
Yeah, thank you.
I've learned from then, I always take a Southern Hemisphere planisphere with me because I don't know the southern sky. I'm sure some of you probably do. But apart from the principal stars and constellations, I'm lost.
I think you should add that to your list of things that you have to do as an astronomer. Check your location.
Check your location where you are. You never know what you're going to look at.
Yeah.
And I remember looking at the first time I ever went to South Africa on holiday with my family, and I looked at the moon. Now, most people just see the moon in the sky, don't they? But if you're an astronomer, you know where the Sea of Tranquility is and the ocean storms and all the rest. And I'm looking at this full moon in South Africa thinking, it's just wrong. It's upside down. There's something fundamentally wrong with the moon. And of course, it wasn't anything wrong with the moon. It was me. Good fun.
I have the same problem when I visit my family in Australia, and I just cannot get myself orientated at all because the sun's in the wrong place. It's
everything's wrong. It's just they live down there.
It's in the north, and I just can't get used to it. I'm still looking at David Lasham.
Just one quick point. I think you mentioned about solar cycles, the 11-year solar cycles.
Yeah.
years ago, I was rather irresponsibly, somebody asked me to teach economics, which was my worst subject at university. And somebody in the 19th century noticed a positive correlation statistically between 11-year trade cycles and activity on the sun, and tried to evolve a theory that the trade cycles correlated, you know, with the activity on the sun. Of course, it was a complete spoof, you know what I mean?
Right.
You can correlate anything statistically, also flight of birds and birth of babies and everything. Doesn't prove that one caused the other, but sometimes people have some strange theories.
They have 2 and 2 and get 5, don't they?
Yes, yes.
Well, David, I think maybe there's going to be a big spending spree coming up, if that's right. Ayansha.
Yeah.
Hello.
I have a couple questions. My first one is, how is the form of aurora dependent on the amount of acceleration of particles?
Ooh, good question. I'm not sure I fully understand what you're asking me, but are you basically asking how does aurora form? The light gets formed. If you are, what happens is as the incoming solar radiation hits a molecule, it excites the electrons going around the atom to a different energy level, and they give off energy in the form of light. And then, of course, eventually the electron goes back to the same electron shell. So that's as far as the particles go. Was that what you're asking?
Yeah.
Okay, and what's the other one?
On what basis do auroras change their colors?
Depending on which of the molecules and the height of those molecules the incoming solar radiation hits them. If it's high up, you get the red auroras. If it's lower down in oxygen is the most prominent element for giving us the aurora. But depending on the height of that molecule in the Earth's atmosphere, that changes the color, because of course I don't quite understand the mechanics of it, but that's been proven over the years. It's to do with the molecules and the height above the Earth. Good questions though, thank you.
Okay. Ian Hargreaves.
Yes. Hi, Howard.
Hi,
thank you for your talk. Very interesting. Thank you. So from the diagrams that you put up.
I'm sorry, Ian. I've accidentally muted you.
You've muted yourself. You're cut off in your prime then.
No.
Can you repeat your question?
Yeah. Sorry, Howard. Yeah, I was muted by somebody not to be mentioned. Not anyway, Howard. In your slides that you put up, you had various different energy levels or aurora levels. I can't remember what that figure was, but you had about 8 or 9 of the different levels, and you show the
KP levels.
Yes, KP levels. Thank you. And you showed the circle descending or getting bigger around the poles. Does that mean that you don't see aurorae at the poles?
No, you still see them from the poles, but of course you'll see them. If you were to stand at the North Pole, any aurora you're going to see is going to be south.
Yes, yes.
But not that far south, because you're not that. Although the map shows the northern extremity of the aurora doesn't move, because of the curvature of the Earth and all the rest, you'd still see the aurora from the poles. And I believe I've seen videos of aurora seen from the poles, where you actually get the aurora literally sitting on the horizon all the way around, not just on the northern horizon.
Yes, but you don't get them overhead. You don't get them. Oh, right.
No, you don't get overhead. Once you get above that auroral oval, the auroral oval does not move. It might move a little bit north, but not much. It's the spreading south as the activity increases. It goes south, but the northern extremity tends to stay roughly in the same location.
So, if I may, a supplemental question on that: why is it set in, why does it form that?
I couldn't answer that. I know it's based on the magnetic pole of the Earth and not the geographical pole of the Earth, but why you don't get aurora overhead at the North Pole, I'm afraid I couldn't answer that one. It's a good question, which I'd have to find out about.
Okay, thank you.
Never thought of that.
It's a bit of a complex issue. Paradoxically, it used to be thought that when there was a northward directed interplanetary magnetic field, there was no aurora, no nothing, very quiet from the point of view of geomagnetic activity. However, it was shown about 20 years ago, as recently as that in fact, when there's a northward magnetic field, much of the activity actually occurs within the polar cap. So it's a bit of a reverse of what used to be thought about the way in which aurora occurred. Of course, again, where people live, not in the polar region. So there were very few reports of the aurora from the actual polar region. But in fact, it turns out that there are some very interesting aurora that occur when there is a strong northward value of the Atlantic field.
I realised that.
Okay, thank you, David Reeds.
Into that.
And just remember that if you're standing at the North Pole, every direction is south.
Exactly. Exactly.
All right. So
all done with mirrors.
You're going to tell me
okay.
Next.
We've worked Howard really hard this evening, ladies and gentlemen. So I think we'll bring the question and answers to a finish there. So can we finish off by giving Howard Parkin a big Mexperience to International Society? Thank you. Thank you very much, Howard.
My pleasure. Thank you all very much indeed for listening, and I hope you enjoyed it.